Pine. Pine. Apple. Apple.
This child is using a unique new educational device. From matching geometric forms, she goes on to match letters of the alphabet. She's teaching herself to read. This pigeon is matching the same geometric forms that the child matched. It's also learning a new skill. Child and pigeon. Today we shall find out what they have in common and see how a pigeon can help us penetrate the mysteries of human behavior.
Conquest, the search for new knowledge about our universe, our world, and ourselves.
I'm Charles Collingwood. This is Harvard University's Psychological Laboratories. What is behavior? What makes a man love, gamble, write a sonnet? In this laboratory, scientists seek answers to those questions using pigeons to stand in for human beings in their experiments. We'll watch science exploring the control of behavior in just a moment. This is Dr. B.F. Skinner, professor of psychology at Harvard. His area of particular interest is behavior. Dr. Skinner, what are you doing with this pigeon?
I'm getting ready to demonstrate a fundamental principle of behavior. The apparatus is quite simple, but the principle is far-reaching. Not only in explaining the behavior of pigeons, but in analyzing human behavior. This pigeon is hungry, and I can give it food just by pressing this switch, which operates a small food dish back of the square opening in the wall. The principle I want to demonstrate is called reinforcement. It's what the layman usually calls reward, although that term doesn't fit too comfortably in many applications. This point is a quite simple one. Whatever the pigeon is doing, when I press this switch, it will tend to do again. And in that way, I can select parts of its behavior and make it do practically anything I like.
Well, now, what sort of thing can you make the pigeon do with this form of reward or reinforcement?
I'll try to turn the bird around counterclockwise toward you. Every time it moves its head around this way toward you, I'll pick that up. And with a little luck, we ought to have a complete turn in very little time. I'm waiting until the head moves this way and then reinforcing. I want to wait for a somewhat bigger turn. That's enough, I think. It takes a little skill to anticipate just the movement that you want to reinforce, because this must occur at the very moment of the response. We're getting the beginnings of a counterclockwise turn. There we are.
Yeah. Come on, pigeon.
A little bit more and he'll go all the way around, I think.
There, he made it. That didn't take him very long, Dr.
No,
Skinner.
that's pretty fair. It varies a good deal because, of course, I have to wait for the behavior in order to reinforce it. People don't realize this, especially in working with children. You must wait until the child does something to reinforce it to get the effect.
And you feel that this kind of reward or reinforcement plays a very real part in human behavior as well as that of pigeons?
Very definitely. We have not as much experimental evidence with the human subject, but we have a good deal. And the principles that have emerged from this kind of research do hold remarkably well.
Now, a pigeon, of course, is simpler than a human being. How complex can you make a pigeon's behavior?
Well, it's a matter simply of my own patience. You can slowly shape almost any kind of behavior. 2 or 3 years ago, in a classroom demonstration, just to see what we could do, we designed a little piece of apparatus in which 2 pigeons could play ping pong. The 2 pigeons are at either end of a small ping pong table. One pigeon pecks the ball as it comes toward him and knocks it toward the other pigeon. Other pigeon pecks the ball back across the table. If it goes past one pigeon, the other pigeon can eat, and if it goes the other way, the other pigeon eats. So that there is it's a real game. The pigeon is reinforced for a cross-court shot if that is what gets the ball past his opponent.
That's remarkable.
Of course, we're not interested in behavior because it's amusing or dramatic. We want to study its causes and find out how to change it. Actually, our experiments are run automatically by rather complicated equipment. Each of these panels contains relays, timers, clocks, and so on, which turn on stimuli, arrange for reinforcement, and record the bird's behavior. Each panel controls an apparatus in the next room. Here are 20 boxes, each of which contains complete equipment for studying the behavior of a pigeon or any other small animal. Here, for example, a pigeon is being put into the apparatus for its daily run. In this case, we are studying how behavior changes when we make the pigeon more or less hungry. By feeding it different amounts of food daily, we can change its body weight and study the effect of this on its behavior. In this box, we're studying the color vision of the pigeon. We reinforce it for pecking the key when it is one color and not when it is another. This work is related to research on those substances in the eye which enable us to see color. No one really cares about why pigeons peck discs. However, it enables us to study the behavior because the response will operate automatic equipment to record and program sequences of events. A paper tape simply moves very slowly over this cylinder, and a pen will move one small step across the paper as the pigeon responds. The bird then draws a line, the slope of which depends upon how fast it's going, enabling us to follow changes in the bird's behavior over a period of time. All this apparatus is run right around the clock, and as a result, we record and analyze hundreds of hours of behavior every day on a wide variety of subjects. Perhaps if we went to the laboratory of my colleague, Dr. Herrnstein, we could see something a little closer to the actual experimental work that we carry on in these laboratories.
We reinforce the bird for pecking when the light is on, but when the light is off, the bird is not reinforced for pecking. As you see, the light comes to control his behavior. When the light is on, he pecks. When it's off, he doesn't. This process we call stimulus discrimination. The control exerted by that light over the bird's behavior can be very strong, as you can see.
Yes.
There are comparable situations in human behavior. We've learned to cross the street when the light is green and not to cross the street when the light is red.
Well, some of us have, Dr. Herrnstein. There's still a good many people who cross the street on a red light.
That's because they get away with it occasionally.
That's true.
If we let the bird get away with it, he would do it too.
As a matter of fact, that's a good example of another type of work we do here with this particular type of experimentation. The things we do in everyday life don't always pay off, and they don't always not pay off. It isn't simple all or none. We are often intermittently reinforced, and there are various schedules according to which what we do can be reinforced intermittently. We study that, in the case of the pigeon, by arranging various schedules or systems of payoff.
The bird is on what we call a slow-down schedule. In order to be reinforced, the bird must wait at least 10 seconds before he pecks. This indicator here shows the seconds going by. It has to go all the way to 10, and then a peck is reinforced. A If he pecks too soon, he must start waiting all over again.
It takes a lot of patience.
This is a very hard schedule for any sort of animal.
Including man.
He made it, didn't he?
Yes, he did.
Yeah.
Can you build this bird up to a fixed ratio?
Well, I'll try.
What do you mean by a fixed ratio?
Well, that's our term for what in industry would be called a piece rate or piecework pay.
The bird is reinforced for every 10 pecks he makes. There, he's reinforced.
And you feel, Dr. Skinner, there's an analogy with piecework in a factory to this?
Yes, the human worker is often paid off in terms of the number of items he produces, the number of times he operates a press, something of that sort. As a matter of fact, a very similar schedule is a sort of piecework where you can't quite predict the next payoff, but one will occur in time, and that is the heart of all gambling apparatuses. The so-called variable ratio schedule, which is built into all gambling devices and produces with human subjects, just as it does with pigeons, a very high disposition to continue to operate a device, like a slot machine, and a tendency which, by the way, continues a long time in extinction when the device no longer pays off at all.
Now, you're trying to deduce laws of behavior for all organisms from this
Yes,
kind of work.
yes.
Would you say that this lack of free will in the pigeon also means that human beings don't have free choices in what they do?
Clinical psychology, scientific psychology, economics, political science, and so on, all contribute to the total evidence that there are external causes of human behavior which, in a sense, do explain the behavior. Now, we are by no means in position to argue at the moment that all human behavior is controlled, but that would seem to be the goal in which scientific research is drifting.
And that a human being has no more real control over his actions than, say, a molecule does under the pressures that exist in its environment?
I think that's a worthwhile assumption. Where these techniques have been tried on human subjects, the same kinds of results are obtained.
Of course, the kind of behavior that you've been analyzing is pretty primitive behavior. Are you able to produce and to analyze more complex behavior?
Dr. Herrnstein has been changing his apparatus, and perhaps we can see an example of a fairly complex process, the kind of thing which in man would at one time have been called a higher mental process.
Now we have 3 keys. As you can see, a stimulus pattern appears on the center key that's either a cross or a circle. The bird must peck this form, and then the 2 forms appear on the 2 side keys. The bird must then peck the same form that he had just pecked in the center. When he does that, he's reinforced. We call this matching to sample.
Now, that's pretty complex for a bird, isn't it?
It is a rather complex form of behavior.
He's doing very well. Now, what does this complex behavior on the part of the pigeon teach you about the behavior of humans?
Well, there's a perfectly simple parallel. Here is a similar device which can be used to teach a child to match patterns, forms, colors, and so on. In fact, it could be used to teach reading. In the early stages, a child begins by matching patterns like these, which are very similar to those we saw in the case of the pigeon. At this point, the child is reinforced simply by operating the machine and moving on to new material. At a later stage, she's matching letters, first simply as geometrical form, but later as genuine letters in the alphabet. And at a still later stage, she is selecting the word which correctly describes a pictured object.
Dog.
At every stage, operating the machine
Apple.
brings new and interesting material into view, and this is enough to reinforce the child so that she will continue to work for long periods of time. Eventually, in this way, she acquires a considerable reading skill. This is our self-instruction room. These students are studying with the aid of a device which is based upon very similar principles to the one we've just seen. I think the best way for you to see how it works is to try it. Here is a set of materials designed to teach the very principles we've been talking about today. This first frame has a word missing. It's up to you as a student to read it and supply that word by writing it on this strip of paper.
All right. Performing animals are sometimes trained with rewards. The behavior of a hungry animal can be rewarded with food.
Well, you put it down and the machine will tell you. Now lift the lever aside. Your answer is now under a transparent cover, so you can't change it. We don't trust you. And the true answer has appeared there, and as you see, you are right.
It says food.
Then, since you're right, move the lever to the right. That means that that particular item will not appear again as you go through this material, because you've answered it correctly. Now put the lever back in the original position, and the second item appears.
A technical term for reward is reinforcement. To reward an organism with food is to reinforce it with food.
Well, see what the machine says.
Reinforce. Pull this up. Reinforce.
That's right. So you move it to the right to record the fact that you got that right, and go back. There's the next item.
Technically speaking, a thirsty organism can be reinforced with water.
Right. I shouldn't tell you that because the machine's going to tell you.
Reinforced. Note, not reward.
Not reward. Reward
Yeah.
would have been wrong because you were asked to speak technically.
Right.
Now, you notice how small each step is. You don't make very much progress, but you always make some, and you are almost always able to make progress. The student does not study before he comes to the machine. The machine teaches him the whole story, and each step is so small that he is almost invariably right, even though this is unfamiliar material.
Now, is this as effective as reading a text or listening to, say, Dr. Skinner give a
Well,
lecture?
it's much more efficient, I'm sorry to say, than the latter, and I think also than the former. The student, we're studying with a text. He has to read. He doesn't know whether he knows it yet or not. He's looking forward to that hour test a month away. And the only reinforcement he gets from this is something which is very far in the future. With this, he knows immediately whether he's right or not. And our students report that they do this with no feeling of effort. They don't need to force themselves to study. And they retain, as far as we know, even better than in the other type. And the saving in time is very great. I don't have figures to support this, but I would risk the statement that with this type of arrangement of material, you can learn the same amount in about half the time with half the effort.
Now, this is a good deal farther advanced than what the pigeon was doing, isn't
Yes, it certainly is. This is verbal behavior, and the analysis of verbal behavior in these terms is quite complex, I'll admit. However, there are certain elements of similarity. We do insist upon quick reinforcement. We insist upon the slow development of new forms of response so that each step can be taken and is then reinforced.
Reinforced by my feeling of pleasure, of accomplishment that I've got it right.
Well, I wouldn't allow myself to say it just that way, but you are reinforced by your success, and I think it's a very gratifying characteristic of human behavior that success is itself reinforcing. We don't need to give you gumdrops every time you're right on this.
Now, with a machine like this, or with this technique of yours, you can train people intellectually. What about emotions? Have you done anything on emotional training?
Well, that is a very difficult problem. You're quite correct. This is only concerned with verbal knowledge. And I'll admit that education should face the problem of emotional training, too. we are doing some experiments which seem to offer a beginning of an advance in that direction. And perhaps if you'd like to see them, we can go back to the laboratory and I can show you an experiment which at least suggests the possibility of an approach to the problem of emotion more or less in the same terms. The pigeon is not known for its aggressive tendencies. On the contrary, it's a classical symbol of peace. So let's put two doves of peace together.
Oh, they're fighting.
They are, and quite viciously. In fact, I can't leave them together very long, or they will hurt each other quite seriously. Now, if these were two boys in a street gang, this would be a social problem, and many kinds of answers would be proposed to it. If you assume that this is some basic physiological pattern of aggression which has to be treated as such, the solutions are very difficult. Therapy would be a very extensive sort of treatment. However, these birds were not always aggressive. In fact, at one time they were quite peaceful. What happened to make them aggressive, I can show you by putting in another bird to exhibit a kind of reinforcement of aggression which produced the results you've just seen. Now this pigeon, when the green light is on, as you see on the word on the wall, this bird is occasionally reinforced for attacking the other. Meanwhile, you see this bird is protesting peacefully. The aggressor is aggressing because of what he gets out of it. Now, when I change a stimulus, I've turned off a green light, and you will see that the other pigeon, although it occasionally attacks, is much less aggressive. Now I turn the light back to green again, it will fight in order to be paid off.
Now, why is that, Dr. Skinner?
Well, it's just like the experiment in discrimination we saw earlier. In the presence of a green light, attacking this bird pays off. In the presence of a white light, attacking the bird does not. You'll see a little aggression, but it is still, you see, pretty much under control.
Yeah.
Now, with the green light, comes right back and attacks again.
Yes.
When we first started this, we observed that the aggressor was behaving in a perfectly cool manner, very much as if he were pecking a key on a wall. But as this behavior develops, it becomes more and more emotional. It shows the physiological pattern. The feathers fluff up.
Do you suspect that human beings are taught aggression in the same way?
I think they are. I think you can see that they are both as individuals and as groups or even nations. There are many instances in which one is reinforced for attacking another. And in the world of the green light, where that reinforcement prevails, we will always have problems of aggression. There is a possibility that we can construct some kind of world with a white light in which no one is reinforced for being aggressive, and there's just a possibility that in that case we wouldn't have the problem of aggression to deal with.
Thank you, Dr. Skinner. We'll be back in a moment. Today we've shown how the behavior of a simple pigeon can help science understand the complex behavior of man. The fictions that we invent to explain nature are much more flattering than the truth. Nobody liked it when the Copernican system elbowed man out of the center of the universe, or when Darwin showed that embarrassing link to the lower animals. And now we're being told that all our actions are determined by our environment. Some scientists, more laymen, disagree. But to the extent that this is true, this new knowledge should make it possible for man to raise himself to new heights of kindness, intelligence, and happiness. This is Charles Collingwood.